Okay, we have plotted polar points. We kind of understand the polar coordinate system a little bit now, and we plotted the points. We're going to look at some basic equations. The basic equations aren't that exciting, but some polar graphs get really cool. But we got to start off basic first, talk about some symmetry stuff, and then we'll do some discovery with some of the other stuff that we don't necessarily need to get into here, but I want you to see them and kind of where you're going with it. So just like in the rectangular coordinate system, you have equations in the polar coordinate system, and they can look like a few different things. And instead of having x and y, we have r and theta, which should make sense because those are your ordered pairs, right? So your equations could look like r equals 5, be like theta equals pi halves, or it could be like r equals 3.5 sine theta. Okay, so they will have trig in them because of the theta. So if you're going to have to actually do some calculations with it, it's going to have, you know, a sine, cosine, tangent type thing in it. If it's not just one of those super simple ones. Okay, so just like in the rectangular coordinate system, where if you have an x equals line or a y equals line, those are the easiest ones to graph, right? Also the ones you got mixed up for the longest time. But x equals and y equals lines, those are the easiest ones to graph. So if you just have r equals a number like this, or theta equals a number, bless you, they are super basic, just like they are in the rectangular coordinate system. They don't look the same, but it's still a basic idea here. So what this means with number 1, where r equals 2, well, if I have x equals 2 or y equals 2, x equals 2 means no matter what y is, the x value is always 2, so you get a vertical line, right? Y equals 2 means it doesn't matter what x is, y is always 2, and that's how you get a horizontal line. So here, the radius is always 2. It doesn't matter what theta is. So when theta is 0, the radius is 2. When theta is pi 6, the radius is 2. When it's pi thirds, the radius is 2. Pi halves, the radius is 2. Kind of get the pattern here? And so what do you think this is going to graph in the end? A circle. So we're going to go ahead and kind of plot all these, because the more they're plotted, the easier it is to draw anyway. But you don't always have to plot every single one of them, or very many of them at all. But I just want you to get the idea that that's what's happening. No matter what the angle is, the radius is 2. And then your circle, oh, I can't even draw it when I have all those points. Circle looks something like that. Okay. All right, so then on number 2, the radius is negative 4.5. So when theta is 0, my radius is a negative 4.5, so here's 4, 4.5 would be right about there. When theta is pi 6, it would be a negative 4.5, so I go through the pole. But it doesn't really matter that I'm going through the pole, because this would be the same graph as if it was just positive 4.5, because eventually we're going to go all the way around the circle. So again, you wouldn't necessarily have to plot them all, but because it's halfway in between, I am going to plot more of them, or my circle won't even look like a circle when I try. So just think about what it means when we say that, you know, r equals negative 4.5. This means that's what the radius is no matter what. Nothing else is affecting it. You get a circle that looks like that. Everybody okay with that? Alrighty. So let's look at number 3. Number 3 says theta is pi thirds. So when I go to pi thirds, when theta is pi thirds, the radius is 2. When my radius is 4, I still am at pi thirds. When it's 6, I'm still at pi thirds. When the radius is a negative 2, I'm still at pi thirds. And a negative 4, still pi thirds. Negative 6, still pi thirds. What's this going to give me? A line that goes through pi thirds, always. Bam. Everybody okay with that? Any questions at all? All right. So, negative 7 pi 6. What is that as a positive angle? Positive 5 pi 6. So, negative 5 pi, or negative 7 pi 6 is at 5 pi 6. So I'm going to plot a couple points on both sides so I can actually hit them. And then, bam. You only have to plot 2 points to get a line, but, you know. Good enough there. Everybody okay with that? Those are super simple, right? So if you just have theta equals something, it's just going to be a line on that angle. And if it's a radius equals something, you literally get a circle that is centered at the origin with this radius. This is your radius of the circle. That's all it is. Okay, everybody okay with that? All right, good deal. So let's look at the little bit more complex ones. It says to graph the equation below, plot points using a table, then connect it to a smooth curve. So we're going to, before we plot points, we're going to come up with this table. We're not going to do a table every single time. This first time so we can think through what's happening. But so when sine is 0, or when theta is 0, what's sine? 0, and 2 times 0 is 0, right? When theta is pi 6, what's sine? When theta is pi 6, sine is 1/2. 1/2 times 2 is 1. Okay, so go ahead and fill in the rest of that chart. All right, do y'all agree with my chart? All right, and one of the angles that are not on here that I wish were on here are the pi 4th angles. We're not going to write all of them, we'll just do pi 4ths. If the theta is pi 4ths, that means sine is square root of 2 over 2. So here I would put square root of 2. Okay, so we're going to use that one as well. In order to estimate some of these, there's some values you kind of need to know, right? And that would be the ones that aren't whole numbers. So like square root of 2 over 2 and square root of 3 over 2. Like I don't care about this one. I can figure that out from knowing these. But these are the trig values that are going to come up over and over again. This is about 0.7. You would never use that to calculate anything or to as a final answer because it's not 3 decimal places. But for graphing purposes, it's close enough because you can't get any more accurate anyway. And that's about 0.9. So if you can just get those two numbers stuck in your head with those, then you can work through everything else. So let's plot the easy ones first. When theta is 0, my radius is 0, so I have a point right here on the pole. When theta is pi 6, my radius is 1. Then I must... Anybody going? You can go if you want to go. Okay. So this is, I lost my train of thought now. Okay, now we're going to skip this one for now because it has to be an estimation. Let's do the easy ones. Pi halves is at 2. So when the angle is pi halves, my radius is 2. Always pay attention to the scale on that polar axis because it's, you know, it hasn't been exactly the same every time. And then when I go to 5 pi 6, the radius is 1. Totally did not do that. Oh, that is 1. Okay. Did I do the right thing there? There we go. Okay. Sorry, I have to be like in front of it to see it. All right, so then when I get to, I'm going to skip this one also. So then when I get to pi, my radius is 0. Well, I already have a point there. When I go to 7 pi 6, my radius is -1. I already have a point there. When I go to pi halves, it's -1. So basically, this whole side right here is just repeating what I already had, right? It's plotting on top of it. So I didn't really need to go all the way to 2 pi. I really could have just gone from 0 to pi, and it would have graphed it just fine. Now, just from those 4 points, we don't know what the heck that thing is. So let's go back and do the other ones that we need to think about a little bit more. So when I go to pi thirds, it's the square root of 3. Well, square root of 3 over 2 is about 0.9. So square root of 3 would be about 1.8, right? So we go about 1.8, looks right about there. And then when I go to 2 pi thirds, that's also the square root of 3, so it's about right there. Then we had pi fourths, right? So pi fourths was like the square root of 2, which is like 2 times 0.7, which is about 1.4. So it's about right there. And then 3 pi fourths, also going to get the same thing right about there. So now we have this thing, and you've never graphed these before, and so this look, it can be a little bit deceiving. If we actually plotted more points, if I actually plotted the 7 pi 12ths, or the other pi 12ths angles, it would help our picture a little bit, look a little bit better, but we don't need to get into all that. We don't even always have to graph all of these. I just wanted to, at this point, to kind of have an idea of what was going on. What does it look like it might be? A circle. I know it kind of looks like it grows up this way, you know, but it's actually a circle, and it is a circle. So once you get some points in there, you just do the best you can to make it a circle. Because let's be honest, even on the rectangular coordinate plane, they still look like eggs and footballs when we drew them, right? So it's fine. We just make it look as circular as possible. It does end up being a circle. That's actually better than I did last period, but it's still, I know it doesn't look beautiful. If you graphed this on some graphing software, it's going to graph a perfect circle. But with us estimating with these decimals and us not being great artists, most of us anyway, you know, it's going to look a little funky, but that's okay. But the circle is tangent to the polar axis here, right? And for this sine one in particular, it is symmetric to the pi halves. Okay, we good with all that so far? So we're going to go through the same kind of thought process, but not necessarily, you don't need to make a t-table every time. That's just not necessary. These values here, however, do need to be in your brain, okay? Something that kind of like with the logs and stuff, you just kind of have to know some of them. So let's do number 6. So we're going to graph this, and I have r equals cosine theta. So when theta is 0, what is cosine? 1. Okay, so at 0, I have a value of 1. When theta is pi 6, what is cosine? It's square root of 3 over 2, which is about what? 0.9. Okay. When it is square root of 2 over 2, or I'm sorry, when it's pi 4, it's square root of 2 over 2, so that's about 0.7. Pi thirds is 1/2. Pi halves is what for cosine? 0. Okay. So then when I go to 2 pi thirds, what's the cosine of 2 pi thirds? Close. Negative 1/2. 2 pi thirds, I go to negative 1/2, so I have to pass through here and end up right there. 3 pi fourths is negative square root of 2 over 2, so I go back through here, and it's a negative 0.7. 5 pi 6 is negative square root of 3 over 2, so it's about right there. Okay, and so this one will look a little bit more circular, because the smaller it is, the better. The bigger it is, the more spread out it looks weird, but there's your circle. This one is symmetric to the polar axis, not to pi halves. Okay, everybody okay with that? All right, let's graph number 7 together, and then I'll have you graph number 8. So I have r equals negative 3 sine theta. All right, well, when theta is 0, what is sine? 0. When theta is pi 6, sine is 1/2. Times a negative 3 gives me a negative 1.5, right? So at pi 6, I go a negative 1.5, which is like right here. I cannot get on the right one. Right there. Is that right? Yes. Thank you. This does not look good. All right. So then when I'm at pi fourths, sine is the square root of 2 over 2, which is about 0.7, times a negative 3 is about a negative 2.1. Then I go to pi thirds. Sine is going to be square root of 3 over 2, which is about 0.9 times 3 is going to be a negative 3 is going to be a negative 2.7, which is about right there. And then pi halves, sine is 1 times a negative 3 gives me a negative 3. Now, is there going to be some symmetry here? There is, right? Because we're going to keep going, right? And we know it's going to make a circle at this point. And so now you can just use your symmetry to get those other points on there, and you don't have to necessarily think through them. This one is going to be right here. and then you just do your best to make it look like a circle. Honest effort is what I'm looking for. This is not an art class. And that's not really that good. Any questions at this point? All right, I want you to try number 8 then. All right, so this is where I got my points here, because we got when theta is 0, cosine is 1, so I'm here at 4. When theta is pi 6, right, cosine square 3 over 2, which is about 0.9 times 4, which is about 3.6. And then this gives me 0.7 times 4, which is about 2.8. Then this gives me 1/2 times 4, then 0. And then I've got some symmetry because they keep going around. Then I just do the best I can to get that circle there. Okay, any questions? Now let's just look at these for a minute, right? So the cosine graph is symmetric. Both of these cosine graphs are symmetric to the polar axis, right? The sine graph we had on the front and on the bottom was symmetric to pi halves. This one's to 3 pi halves. So basically this, in last period somebody said the y-axis. So we understand there's the y-axis there, right? But there's no taking away of you thinking about the x and y-axis. I mean, you've been doing that forever. And so your brain is still going to think that way, and that's fine. Because if I took an x and y-axis and I superimposed it on top of this, the graph would look exactly the same. Because there are these coordinates that we plotted. They exist in the xy coordinate system also. We just don't know what they are yet. So thinking about x and y is not a problem. When you're plotting things like on the unit circle, was your x value cosine or sine? X is cosine. So cosine is symmetric to the x-axis that your brain's thinking of. Your sine is symmetric to the y-axis that your brain is thinking of. Does that make sense? It's just the polar axis and the x and the pi halves. So you don't want to completely forget about x and y because these are related, and we are going to go and convert back and forth, and we need to kind of understand that. So when you're trying to figure out, and so this is negative, that's why it's down here. It would be positive, it would be up here. Both of these cosine graphs are positive. So if this was a negative, it would be on this side, but it would still be symmetric to this axis. Does that make sense to you? So try and make sure that you kind of see the big picture of these also, and not just, step by step on what to do. Well, the polar axis is this. It's the ray that we have. There isn't an axis here. Like this ray is literally the only axis. We don't even have a negative one. Does that make sense? So it doesn't exist, but I know in your mind you're still seeing it. Like you can't not see it. And I mean, I look at them that way too. But they don't really exist on this coordinate system. Okay, we okay with that? All right, now let's look at cosecant. Cosecant. What is the reciprocal of cosecant? sine. So r is equal to 1 over sine theta. Way easier to think in terms of sine, cosine, and tangent than the reciprocals because those values we know. It's okay not to just be able to rattle these off just yet because, you know, it just comes with time. But so we can think in terms of sine and it's fine. So when I go to substitute things in, when theta is 0, what's the sign of 0? 0. So what is 1 over 0? Undefined, which means I don't have a point to plot here. Okay, so let's move on to pi 6. What's the sign of pi 6? 1/2, right? And so 1/2, and the reciprocal of that is 2. So at pi 6, I really am at 2 because it's cosecant. Okay. So when I go to pi 4ths, the sign of pi 4ths is the square root of 2 over 2. And then, I mean, I could do the rationalizing and stuff, but I know the decimal for the square root of 2 over 2. I don't necessarily know what that reciprocal is. Let's skip that for now. Even the square root of 3 over 2, let's just skip it for now. Let's move on to the next easy one. Pi halves, what's the sign of pi halves? 1. I multiply that, or I take the reciprocal of 1, and I get what? 1. So at pi halves, I'm at 1. So we're going to skip 2 pi thirds and 3 pi fourths again because those are yucky numbers that maybe we don't even need to use. Go to 5 pi 6. The sign of 5 pi 6 is 1/2, and then the reciprocal of 1/2 is 2. So at 5 pi 6, I'm at 2 again. Now, just looking at those 3 points, what does it look like is happening here? It looks like a line, right? Because those 3 points look like they are, what's the word? Collinear. Good job. So those 3 points are collinear. So since they're collinear, the other ones that I didn't plot, I don't even need, right? They are collinear. They don't just look that way. So what you get here is a horizontal line. Bam. And so now, I didn't plot the other ones, but I can tell you that if my picture was accurate, which I'm quite sure it's off a little bit, but pi thirds, right? The cosecant of pi thirds is a little bit more than 1, and the cosecant of pi fourths is a little bit more than 1/2, right? As far as, you know, the estimates go. But it doesn't even matter because we get the line. We good? Let's look at secant here. R is equal to 1/2 times 1 over cosine theta, right? And we don't need to like combine them or anything. It's actually easier to think of them separate. So when theta is 0, what's cosine? 1, right? And then 1/2 times 1 is just 1/2, so I get a point right there. So then I go to pi 6. What's the cosine of pi 6? Square root of 3 over 2. Let's skip it. Square root of 2 over 2. Let's skip it. What's the cosine of pi thirds? 1/2. What's the reciprocal of 1/2? 2 times 1/2 is 1. So at pi thirds, I'm at 1. I go to pi halves. What's the cosine of pi halves? 0. 1 over 0 is undefined, so I can't do anything. I go to 2 pi thirds. What's the cosine of 2 pi thirds? Negative 1/2. I'm sorry, negative 1/2, which means then that the secant is negative 2 times 1/2 is going to give me a negative 1. So at 2 pi thirds, I go to negative 1, and I'm right there. And what do you think this is going to be? A vertical line. Bam, there you go. Oh, I totally missed my line. Points. There we go. So let's again think about the XY coordinate system. Your vertical lines in the XY coordinate system, bless you, were they X equals or Y equals? Vertical lines in the rectangular coordinate system, X equals, and cosine is your X value, right? Your horizontal lines are Y equals, and sine is your Y value. Okay, so you can keep them, they're still working out that way. All right, questions? All right, so I want you to do number 11. You will go off the grid a little bit. It's okay, make it work, and then I'll show you how I would help myself make it work once you've got that done. That's what it would look like. What I would suggest if you go off the grid is if you just extend the angle line that you have, then you can kind of estimate how, how many steps to go out that way. If I don't put that little line out there, my points are going to be not even close to where they need to be. It's hard to even estimate. Okay. Any questions on how I got any of that, though? Are we all good? This isn't that bad. It's just different, right? And then if you can connect it to what you already know, it's going to make it that much easier, especially when we start converting. Okay? Any questions at all? Question? No? We good? All right, so then grab the homework. Even if you're not done with this, there's a mistake, of course, because why wouldn't there be? So I want to make sure that you know what that is so you can fix it. Number 15, theta equals theta over 4, makes absolutely no sense. This should be pi over 4. Change that to pi over 4. Okay. And then if you need to go back and finish the other graph, just make sure you change that.